Where smaller streams meet larger ones, you often find a deposition of material. While it may not be obvious on a day like today, but in addition to water flowing down these channels, sediment does as well. Very little is moving today with the low flows and clear water, but as the amount of flow in these rivers and streams increases, so does the amount of sediment they carry, quite dramatically. With increased flows comes higher speed of water coming down the channels. Higher speed means that a river is able to transport more sediment per volume of water. And there is also more volume of water that is flowing, so a lot more sediment flows down channels than with high flows than with low flows, because there are so many factors which are increasing the amount of sediment that is transported with higher flows. It's not just the sediment that's suspended in the water, but also the sediment that is rolling and skipping down the bed load. In this footage, you can see, even with clear water, some smaller particles are being moved along the bottom of the channel. Because the density of sediment transported depends on speed, where water slows down, it drops out of the flow. That is why deltas form as rivers enter the ocean or lakes. It also occurs where side streams enter larger rivers, as this gravel bar island evidences. In this location, the Green River empties into the Lamoille. Typically, the farther up in a watershed you get, the steeper the rivers and streams are. The slope of a stream channel is one factor in determining the speed of water flow. Higher flow speeds can transport more and larger size sediment. When that steeper side stream enters into the larger, flatter, and thus slower river, it cannot transport those same larger particles or the relative volume of sediment, and thus it deposits, in this case, slightly downstream of where the tributary enters. At this other location, upstream along the Wild Branch, which is a tributary to the Lamoille, the deposited sediment is directly out in the river, with the side stream having maintained a separate flow path for a bit. This site in North Wolcott Village is a great example showing the existing bed material. Looking upstream on the side stream, the reasonably stable bed materials, boulders on the steep slope which stay in place as the water, and smaller sediment, wash over them. Upstream along the larger river, it is made up of gravels and cobbles, though these were mobile, at least in the larger storms such as the one we recently had. The rapids in the Grand Canyon are thought to be formed in a similar manner, with occasional debris flows triggered by intense rainfall, washing large amounts of rock down the sides of the canyon and into the Colorado River. In the past, spring flooding came through and redistributed this material, mellowing out the rapids. With the construction of the Glen Canyon Dam eliminating these periodic floods, the rapids no longer evolved. High flow events from the Glen Canyon Dam have been performed regularly since 1996 in order to remobilize sediments to maintain sandbars and other features of the river. It's not just where smaller streams meet larger ones that sediment deposits. This stream, as it enters our land, goes from fairly steep to relatively flat. This plain of material was deposited during this summer's high flows, with previous flooding events having deposited material here as well. The water, as it comes down the stream, meets this shallower grade, slowing down, thus dropping material out, as it can't maintain as much material in the flow as it does higher up where it is steeper. Though relatively benign in this location, I know of several roads which cross streams at changes of grade such as this that have repeated issues with sediment depositing there, filling the culverts, thus making them unable to carry water, and thus the water has to go over the road, washing it out. While I see indications in state regulations that they are aware of this issue, along with debris, I think there needs to be more awareness among the designers who are actually specifying the structures that are put in these stream crossings. It's a hard issue to solve, designing fixed infrastructure which you're expecting to stay there for 25, 50, or 100 years for a landscape that is changing, not steady state. I wish I knew a solution for it.